welcome back to my math YouTube channel. In this video I want to talk about a special triangle which is 30 60 90 triangle. So let us look at this 30 60 90 triangle. So guys, I'm going to draw my 30 60 90 triangle. Keep in mind this is not drawn to scale, but I'm going to try my best to make it look like a 30 60 90. So this is my 90 degrees right here, and then guys, this is going to be, I'm going to join this, and let's say this is my 60 degree right here, and this is my 30 degree. So this is my 30 60 90 triangle. So guys, our goal is to kind of figure out the trig ratios for 60 degree and for 30 degrees, but we don't know, there's no kind of a relationship here between the any given angle and the side opposite to it, and we don't know any of the three sides. So guys, we are going to do something extra in this case, in this special case, to kind of figure out the lengths or the ratios, at least the ratios that the sides are, and then from there, because we definitely need to know some of the sides, if not all of them, to figure out or to write the trig ratios. Okay, so what we are going to do here is, guys, we are going to actually draw an identical triangle on the right side of this line right here, this vertical line right here. So if we draw an identical triangle, like something like this. So guys, keep in mind we are drawing an identical triangle. What does that mean, guys? That means this angle, which was already 60, this is also going to be 60 degrees, and if this is 30, this is also 30. So what we are looking here at this whole big triangle, and let me actually name it ABC, and let us call this D here. So guys, ABC is now an equilateral triangle because all the three angles are 60 degrees each. Now we are only interested in a 30 60 90 triangle. We are actually only interested in the triangle ADC, but since we didn't know any of the sides and there was no actual like a geometrical rule or any of those sorts of things that could help us to figure out or take a guess on the lengths of the sides, so we had to do an extra kind of a construction piece. Guys, sometimes we have to do something extra to figure out things, right? So here we added this extra triangle, triangle CDB, but we are only interested in triangle ADC. That this extra piece is only done so that we can figure out the sides. Okay, so guys, once we have an equilateral triangle, which is this triangle ABC, we know all the sides, all the angles of an equilateral triangle are 60 degrees each. They are all this equal to each other. And then we also know if the angles are the same, then the sides are also going to be exactly equal to each other. Guys, we still don't know the exact length of any of the sides, but let us say that one of the sides length is 2a. Sometimes, guys, textbooks or people like to just use any variable a, b, c. Well, I'm using 2a just for convenience purposes. Guys, you are free to choose any variable that you like. You want to use a, that's fine, you can use a, but for convenience purposes I'm using twice a. So if we say that length of this side AC is 2a, then because this is an equilateral triangle, then the length of each of these sides is going to be 2 times a. So guys, we know this is 2a, this is 2a, and also this length here is 2a as well, but we know D is the midpoint, right? Because these are two identical triangles. So if D is the midpoint, that means this length is going to be a, and this also is going to be a, because then only it will add up to 2 times a, and they are basically identical triangles. So this length is supposed to be this length. This is like they're sharing this common side, and then the hypotenuses are also going to be the same, right? So guys, once we have this set up, now I don't really care about this equilateral big triangle ABC. All I need is my 30 60 90 triangle, which is my triangle ADC. So once I have this set up, now I'm going to kind of extract my, or go back to my 30 60 90 triangle. I'm redrawing it so that we don't confuse ourselves with this whole big triangle. So I'm just basically taking away my 30 60 90 triangle that I'm interested in. So that is triangle ACD. If you want to work with that other one, CDB, that's totally fine. That is also a 30 60 90 triangle, right? But guys, I'm going to use this one on the left. So this is my 30 60 90 triangle. This is of course a right triangle, and this is 60 and this is 30. Guys, in this triangle I already know that if this length is 2a, then this length right here is a, but I did not know it. I could not just say that is true without actually doing this extra construction piece. Okay, and then guys, I don't know the length of side CD. Okay, But since this is a right triangle and we have two of the sides, we can figure out that third side. So all we needed from this whole construction piece was the length of the hypotenuse and one of the sides. So guys, let us first go ahead and actually find the length CD. So let us call that, you can call it whatever you like. Let me call it Y, because it's a vertical, so that's why I'm calling it Y. You can call it by any variable you like. So guys, to figure out the length of this, we are going to use the Pythagorean theorem. So using the Pythagorean theorem, it's going to be y squared plus a squared is going to be 2a squared. And to get y squared by itself, I got to subtract a squared from both sides. So it's going to look like 2a squared minus a squared. When we simplify this, it's going to be 4a squared minus a squared, which is 3a squared, but we have to take the square root on both sides to get y by itself. So when we take the square root, it's going to be square root of 3a squared, which is just simply square root of 3a. So now we have the length of this third side, which is square root of 3 times a. So from this, we have all the three sides. So guys, based on these three sides, the 30-60 triangle, the 30-60-90 triangle, the ratios of the sides can be written out as this. So opposite to 30 degrees, I have side A. So I can say A, the ratios of the sides. So ratios of ratio of the sides of this 30-60-90 is A is to then 60. What is opposite to 60? Radical 3A. And then the last one is what is opposite to 90 degrees? That 2a. And guys, it also makes sense because we know that the biggest side, the longest side of a right triangle is the hypotenuse, which is opposite to the biggest or longest or largest angle. In this case, 90 degrees is the largest angle, and 2a is the biggest side. So that's directly opposite to that. And then opposite to the next bigger side is going to be the one which is opposite to 60 degrees, and radical 3 times a is the next bigger one after 2a, and then the smallest side of this triangle is going to be the one which is opposite to 30-degree angle, which in this case is going to be just simply a, right? So guys, this is the ratio. But if we want to make it even simpler, then we can divide these three quantities by an a, and if I divide by a this one, and this one, we've got to divide with all three. Guys, then we are going to get a simple ratio, and we like to work with simple numbers. We're going to get 1 is to radical 3 is to 2. And at the end, we want to use this one rather than using a's. We can use a's, there's nothing wrong with it. But guys, to make life a little easier, it's better to work with divide this ratio by a and then get simple numbers. So basically, what does that mean? That means that 30-60-90 triangle will have the sides in the ratio 1 is to radical 3 is to 2. And sometimes people like to just work with this, and I'm going to do it right here as well. So if this is 60 degrees, then the side opposite to it will be radical 3. So we understand that these are actually ratios, but the simplest one, in simpler terms, we can also think of this as side length radical 3. Then this is side length 2, and of course this length, the smallest, is going to be 1. Guys, you can, if you multiply any one of this by a certain number, then you got to multiply everything by that number. So you can get infinitely many possibilities of actually getting a right angle triangle for 30-60-90, but the ratios are still going to be always 1 is to radical 3 is to 2. Keep in mind, 1 is the smallest, so it is overlapping with, it is going to be opposite to that 30-degree angle. Radical 3 is going to be opposite to 60, and the longest side of the right triangle, which is the hypotenuse 2 in this case, is going to be opposite to that 90-degree angle. Excuse me. So guys, once we have this set up, and how are we able to get this set up? First, we started by drawing that 30-60-90. We were clueless because we didn't know any sides, and we didn't, even from the basics of geometry, we could not just come up with any side. So what we did, we still used geometry, so we kind of did some construction. From that, we could see it's an equilateral triangle. Once it was an equilateral triangle, guys, we know that the three sides of the equilateral triangle are equal to each other. They are the same, right? That is the basic property of an equilateral triangle: equal sides, equal angles. From there, we were able to just come up with, like, let us say one of the side lengths is twice a. From there, we were able to get this set up. We were able to get the missing side, and from that, we can now see how the lengths of an 30-60-90 triangle are. Okay. So guys, this is basically real mathematics, where you start with something and you look at the problem, and we're like not sure what to do with the problem. We feel like there's quantities that are missing, but then we use other concepts, prior knowledge, to kind of bring in other things that we did in this case, to kind of see if by bringing in prior things, we may be able to figure out the solutions. And that was exactly what we did here. Okay, so guys, finally we have this 30, 60, 90 triangle. From here we can easily figure out the sine or all the trig functions or trig ratios for 60° and 30°. Okay, so that is why it is called special. We cannot figure out the we cannot just know the ratios of the sides for any triangle, but for 30, 60, 90 we can do it the way we did it here. And also I did one other one, which is 45, 45, 90 in my previous example. So those are the two special cases. So from here, let us write some of the ratios, guys. If I have to write sine 60, we know sine is the opposite over hypotenuse. So this is the opposite. So it's going to be radical 3 over 2. Similarly, let us write a few other ratios. What about the cosine of 60? Cosine of 60 is going to be adjacent. This is going to be the adjacent and hypotenuse 1 over 2. Then we know the tangent. Tangent is the opposite over adjacent. So it's going to be just radicals 3. Similarly, guys, we can also, you can also write the other 3, cosecant and secant and cotangent, and I will let you do that on your own. But guys, let us also write the sine, cosine and tangent of the 30°. So sine of 30, for that we have to, this is now my new reference angle. So the opposite and adjacent are going to change. So if I'm working with 30°, then the opposite is going to be 1. So it's going to be 1/2. And similarly for cosine 30, it's going to be adjacent over hypotenuse. So adjacent has changed. It is now radical 3 over 2. And then I have my tangent of 30°, which is going to be opposite over adjacent. So which is going to be 1 over radical 3. You got to rationalize and get radical 3 over 3. So guys, these are some of the basic properties and basic things regarding the special triangle 30, 60, 90. We already looked at a special triangle 45, 45, 90. So basically one of the things that we need to kind of take away from these two like special triangles is sometimes if we do not have access to calculators, or we are not allowed to use a calculator, and we need to know, or we need to use the trig functions or trig values for 30°, 60° or 45°, guys, then we have now a way without even like using a calculator to figure those out.